Hello and welcome to this exercise on average speed. I've done two previous videos on distance, speed and time. I hope you've seen them. You need to have seen them to understand what I'm doing here. Now for this video, there are 2 or 4 cases, but I'm doing only 2, pending the 4th case. Now case 1 equal time, case 2 equal distance, and case 3 is where we know the average speed for the whole journey. And we know the average speed for one part of the journey, and we want to find the average speed for the other part of the journey. Now for case 4, we have 2 trains or 2 cars traveling from A to B and then from B to A, and they meet at a point. We want to know at what time they arrive at their respective locations. Okay, I hope all that makes sense. Right, let's see if we can make sense of this. This is Sharon running, doing some exercise. For the first 30 seconds, she runs X meters at the speed of 50 meters per second. And for the next 30 seconds, she runs Y meters at the speed of 10 meters per second. We want to find her average speed. So this is the usual triangle for composite measures. In this case, we're looking at speed, distance, speed, and time. Right, now we've got D, and we've got S for speed, and we've got T for time. Now to find time, you cover up time, and then you divide distance by speed. And if you want speed, you cover up S, you divide distance by time. And if you want distance, you cover up D, and it's speed times time. Right, now we want to find X, and X is distance. So X will be something like the time times the speed, or the speed times the time, doesn't really matter. So X in our case is 450 meters, and similarly Y is 300 meters, because 30 times 10 will give us 300 meters. Now the average speed is the total distance divided by the total time. And so that's going to be 450 plus 300 divided by 30 plus 30. So that will be 750 divided by 600. And we end up with 12.5 meters per second. And that's our average speed. Now, in this case, the times are the same. Okay. Now, let's see if we can derive this. Now, what we then do is the average speed is, again, the total distance divided by the total time. The total distance is X plus Y, the total time is 2t, because T plus T is 2t. We now have to isolate the half, so we end up with X into X over T there, plus Y over T. Now X over T is this speed here, 15 meters per second. And Y over T is this speed here, because distance over time gives us the speed. So that's the second speed at 10 minutes per second. So our average speed is going to be a half into 15 plus 10. 15 plus 10 is 25. If you have that, you get 12.5. And that's what we've got here. Now, please note that in this case, this only applies when the times are the same. When you got different times, that's a different ball game altogether. Right. Now, case 2. Distance is the same, 10 kilometers. But the speeds are different. Right, so we want to find her average speed, because the first kilometer she did at 20 meters per second, and the second one is the next 10 kilometers is 10 meters per second. Now the cycle time, and I call cycle time TC, is 10,000 divided by 20. Now 10,000, because I have to change 10 kilometers to meters to make sure I've got the same unit here. So the cycle time is 500 seconds. And the running time, TR, here, it will be 10,000 divided by 10. Okay, so don't forget, because looking for time here, divide distance by speed. Right, right. So average speed, as before, will be total distance divided by total time, which is 20,000 divided by 1,500. And we get 13 and a third. There should be an equal sign there. Right, I should change that. Okay, now, let's see if we can derive this now. The distance is X, the speed for cycling is SC, and the speed for running is SR, there and there. Okay, so what we've now got is the total distance which is x plus x, divided by the total time, which is tc plus tr. Right, and that gives us 2x, okay, which is here, 2x there, divided by tc plus tr. Now, if you want to express tc and tr in terms of the distance and speed, don't forget that your time is distance divided by speed. So we have tc as x over sc and tr as x over sr. Yes? Okay, now if we isolate the denominator for now, only the denominator, and deal with this one first, the lowest common multiple or lowest common denominator is SR times SC here. So all that now becomes x times SR plus x times SC. Yep. And when we factorize the top bit here, which is numerator in this case here, we have x into SR plus SC divided by SR over SC. Now, we need to combine the numerator and this denominator here, so which means 2x divided by all of that. So we divide it by a fraction. So in this case, the SR times SC will be on top, and that will be at the bottom. So we end up with something like this. Okay? I hope that's making sense. Okay, so we've got 2x times SR SC, because that goes on top, divided by x into SR plus SC. Now the x's cancel out, so you end up with 2 into SR SC divided by SR plus SC. Now let's see if this is right. Now 2 times 20 times what's it about? 20 times, where is 10 is 200. Now 200 there, double that, you get 400. Now 20 plus 10 is, where's it gone? 20 plus 10 is 30. Now 400 divided by 30 hopefully should give us 39 1/3 meters per second. And this only applies, please, this only applies when the distances are the same compared to when the speeds are the same. Now this is different from that one here. Two different things altogether. I hope all that made sense, and please